to write the formula of ionic compounds where we've got slightly more complex ions, you're going to need your table of ions, and this is in your data sheet. Okay, so here we've got some metals which are in that transition block, and it's giving you an idea of the charge that they could have. So copper 1 with a charge of 1+, copper 2 with a charge of 2+. There are also some like silver and zinc, which have pretty much always got the same charge. But we're really interested now in these polyatomic ions, called polyatomic because there's more than one atom in them. Most of them are negative ions, anions. There is one over here, which is the ammonium, which is a polyatomic positive ion. When we look at these, you'll notice that we have, for instance, let's have a look at sulfite here. SO3, 2 negative. This tells us we've got one sulfur. The O3, that little subscript there, that tells us there's 3 oxygens there. And this superscript, 2 negative, that's the charge on the whole thing. So, when we write the formulas, our overall aim is a neutral compound. So what's important isn't how many oxygens or hydrogens there are, it's what that charge is. Okay? If we need more than one of them, we need more than one of the whole thing. So if we look at calcium and sulfate, 2+ and 2 negative already cancel out. So we get a compound which is calcium sulfate, one of each ion. But if you looked at something like barium phosphate, barium's 2+, phosphate's -3. So we're going to need 3 of the bariums to cancel out 2 of the phosphates. To show that we want 2 of that whole thing, we're going to put the phosphate in brackets, and yes, that 4 should be smaller. And then we put a 2 outside the brackets, which means we want to double everything that's in here. But notice that when we only wanted one of them, we didn't put it in brackets. So we only put it in brackets if we need to double it or triple it. Okay? And it doesn't matter, same approach, whether that's an anion or whether it's our ammonium cation that we're needing to double.